So a little bit of comparison now between Venus and the Earth. And this comparison here is really about the issue of CO2, like will the Earth become a Venus or something like that? Well, let's just think about it a little bit here, okay? So I'm going to draw a little picture here. And suppose here's the ground of the Earth right here. And suppose that up here, let's just say this little pink thing here is a little CO2 molecule. Of course, there can be 400 of them for every million at 400 ppm, that kind of thing. But let's just think for a minute here. If you're on the Earth now, what can happen to this CO2 molecule? Well, for the most part, it's just sort of floating around up there. And of course, as you know, as sunlight comes down and infrared radiation goes up, the CO2 can kind of re-emit that infrared radiation back down and sort of behave like a blanket around the Earth. But what can also happen on Earth, of course, is it can rain. Okay, so imagine there's a little water droplet here and some rain, because water is a big part of our hydrologic cycle. And that rainwater is just sort of going to come down here and collide with a CO2 molecule. Well, what happens then when sort of water and CO2 get together? Well, there's a chemical reaction and you get carbonic acid, H2CO3. And so the water droplet just becomes this carbonic acid. So the water itself becomes a little bit more acidic. So I don't know, maybe we'll just sort of draw a bigger drop here indicating the reaction has happened. And it's still sort of like, I don't know, acidic water, if you will. Okay. And so what happens then with the acidic acid, of course, or the acidified water, however you want to think about it, is of course it falls in terms of rain like this. It might fall all the way down. And it gets down here, but what it can do when it gets to the rock, it can sort of dissolve rock a bit. Dissolve rock. Which is, I don't know, kind of interesting. And so what that means, if you have like some rock here on the Earth, then this carbon dioxide molecule, let me just go back to tracking that molecule, because say it's sort of inside of the water here if you want, and now it's sort of going to be inside of this rock if you want. There it is. Did I get my orange on there? Yeah, there it is right there. So it's inside the rock. And the other thing that the carbonic acid can do, or the acidified water can do, say if there's an ocean over here, say there's a bunch of water here from an ocean, as we know we have on Earth. So of course, the carbonic acid can also fall into the ocean, making the ocean a little bit more acidic. But of course, let me just draw the pink dot here. Now our CO2 molecule is down in the water. Okay, so hopefully you can see where this is going here. The point is that the CO2 molecule used to be up here in the atmosphere, and when it rained, it got flushed down and went into some rock and maybe started to dissolve away some rock, or it fell into the ocean and started to actually acidify the ocean a little bit, which can happen. But generally what we see is when the carbon dioxide gets into the ocean, what it'll likely do is just sort of sink to the bottom here. So that little pink carbon dioxide molecule that was once floating around the atmosphere might be down here, bottom of the ocean, or like I said, it might be in a rock like that. And well, what can happen next? Well, if I keep sort of modifying my picture of the Earth here, is maybe this rock right here is sort of on what might be a subduction zone. I guess I don't really need to erase that, but I'll just sort of make it a little clear. Like maybe there's a subduction zone going on like this. Remember those two layers that are going past each other. So this plate's moving this way and this plate's getting dragged down like that. And so what will happen, of course, is our little CO2 molecule might make it all the way down into the molten Earth like that and sort of get, so-called recycled again, because that's what these subduction zones do. They recycle rock, and the carbon dioxide molecule, again, that was once in the atmosphere, might become part of the recycled rock. And then we also know, for instance, that near the subduction zones, that's a very popular spot for volcanoes to exist. So there might be a volcano here. And one way or the other, this little CO2 molecule here might get caught up in the magma chamber and the lava that ends up blowing out of the volcano. So it might start looking something like this. There might be a big volcanic explosion here. Boom like that. But the bottom line is the CO2 molecule might make it back in the atmosphere again. Okay, now I don't know how long this process is going to take, but you have to agree, though, that what you've seen here is definitely a big cycle and a CO2 cycle, something like that. The carbon dioxide was in the atmosphere. it may have gotten pushed all the way down into the earth, into a subduction zone, stewing around in some magma for a very long time, dare I say millions of years, something like that. Or it might sink to the bottom of the ocean, and what happens at the bottom of the ocean? Well, typically it'll get covered by other sediment and that kind of thing, maybe covered like that and just buried down there. But hopefully you see the cycle. Like if I took this purple color here and drew a big loop, you can see this little carbon dioxide molecule went down, 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 and eventually came back up again. So that's what we call sort of the carbon cycle. The carbon cycle. And that's what that is. And there's also even one more aspect to the carbon cycle, which I haven't drawn on here. Let me put on there. Is, of course, trees, trees and vegetation. So there might be some beautiful trees here with some nice foliage on them and stuff. And they suck in carbon dioxide as well. It's part of their living process. So there's a little CO2 molecule might have sort of made it into the structure of a tree. So maybe it goes in and ends up being part of the tree or something like that. And of course, what happens to the tree? Well, eventually dies or burns or whatever it does and makes it down into the ground again. But the point is that it's no longer in the atmosphere. So you just see there's just this cycle, this carbon cycle. Okay. So I'll tell a little more formally about the carbon cycle in the next video.